indicates an amplifier. So I have to represent it with the help of input resistance of amplifier, right? With the help of output signal which is available. So I will be showing it as a source. Okay, so I'm drawing. So this amplifier is having input resistance, let's say Ri. So this is your amplifier. Okay, it is the input resistance of an amplifier. We call it as Ri. Then, because this is a current amplifier, you know what is the input signal to this amplifier and what will be the output signal of this amplifier? Yes, this is a current amplifier. So input will be current and output will also be current. Do you remember yesterday we have discussed this? Yes or no?
Yes, ma'am.
So if input is current, which source shall I show in the input side? If input is current, then I must show a current source. Is it not? Input shall be given with the help of a current source. Okay, so let us call this current source as IS. Okay, so this is, I am connecting the input current source. So I must show the resistance of this current source connected in parallel with this. Right? So I will call this as RS. Ri is the input resistance. So therefore the input current which is flowing in this, I will represent it as II. The current which is flowing inside amplifier is II. Okay. Then what is the output available? What will be the output of this amplifier? This is a current amplifier. So what will be the output?
Current.
Current. So I must show the output as a current source. So my output signal is available in the form of current. So I will show it with the help of current source. Okay, yesterday we learned voltage amplifier. So this was shown as a voltage source because output which was about to be provided by that amplifier was voltage, but now it is current. So I must show here a current source. So this is the current source again. Okay, so when I show current source, you know, the resistance of this current source will again appear in parallel with that. Now what shall I write here? The name of this current source? We always write it in the form of gain. So if this is a current amplifier, then gain AI is equal to output current, that is IO, upon input current, that is II. Now in this case, so what shall I show here? The current, output current which is to be provided is equal to AI, that is current gain multiplied by input current II. So I will call this current as AI into II. AI into II. And I will call this resistance as the output resistance of amplifier. So here now I will connect the load resistance. These are the output terminal. Okay, output current is. So input side, because the input signal is a current, I must show it by current source. And because the output signal is also current, so here also I have to show a current source. Now let us comment. So when Rs is the input resistance of this current source, so how much should be the input resistance of a current source? Yesterday I told you. Yes, less or high? Ideal value?
Less.
Less.
Yes. Less? Is this input resistance shall is less? What is the job of a current source? Everybody. What this current source is supposed to do? In my circuit, I want a current of, let's say, 1 ampere. So to provide this current of 1 ampere, I will use this current source. This is my whole current source. So it must provide me output equal to 1 ampere, right? So here, this is providing 1 ampere. But now look here, the current is getting divided here. Now tell me, if value of RS is less, will this current not flow here? If we apply KVL, this current IS is getting divided into the current which I want, II, and the current which is flowing through this resistance, RS. Okay? I want this whole current at the output, at this point. But if the value of RS is less, RS is nothing but the resistance. If the resistance in the path of current is less, then the current will flow and this value will reduce now. Then what is the use of this current source? ज्या करंट सोर्स कडनं मला 1 एम्पियर एक्सपेक्टेड आहे त्याला 1 एम्पियर आउटपुटला मिळाले, then it is useful. Otherwise, if 0.5 ampere is flowing in this resistor, then I can't say it's a 1 ampere current source. So what should be the value of this resistance?
High.
Lesser or higher?
Higher.
Higher.
High.
Hello? Please speak loudly. Less or
Higher.
high? High.
High.
If this value
High.
is high, a position high, no current will flow through this. So RS, whenever it's a current source, RS must be very, very high. So here, if you compare the RS compare with RI, so this RS should be very, very high as compared to RI. Got it?
Yes, ma'am.
Yes, ma'am.
Everybody, is it clear? Now what about here?
Yes,
Now similar answer I expect from you. Tell me, what about this? RO. What should be the value of RO? This is a current amplifier. Comment on RO. Compare RO with RL. Everybody, please unmute and tell me.
Greater than of RL.
Please speak loudly. You are not audible. Okay, please speak. My volume was itself very less. Yeah, please repeat. Rutuja.
RO is greater than of RL.
Very good. This is also current source. No? So it is applicable. If this value is less, the current will flow here and output load resistance may not get the desired current. So RO shall also be very, very high. एकच लक्षात ठेवा, करंट सोर्स असेल तर त्याचा इंटरनल रेजिस्टन्स खूप जास्त, and if it's a voltage source it should be very less. So RS should be very, very high as compared to RI, that is input resistance of amplifier, and RO should be very, very high as compared to RL. Very important. Now what is the gain? I already wrote here what is gain equal to for this amplifier. Gain is AI and it is indicated by right? What is gain? AI. When you write the description, so these three things must be covered. It is output current upon input current. Okay, so output current I am indicating as II, which is going inside, and output current is this current IO. I am calling this current as IO, which is equal to AI into II. So if you see, if this is ideal amplifier, then whatever is there, it will become your II, and whatever IL is there, it will be same as this current. So in other words, I can say that it is equal to the output load current, okay, because this is the same as load current and input current is IS. Okay. Is it clear? Current amplifier? Is the current amplifier clear to you?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay, now I have to draw next transconductance. So you will tell me how shall I draw? What shall I show at input and what shall I show at output? Accordingly, I will draw transconductance. Next amplifier, I want a transconductance amplifier. So what will be the input signal? Tell me.
Voltage.
Okay,
Current.
and what will be the uh, voltage or current? Transconductor. First of all, remember the formula of transconductance. Conductance. What is conductance?
1 upon R.
Very good. 1 by resistance. So what is formula ratio of V to I or I to V?
I to V.
I
I to
to
V.
V means what will be the input and what will be output. Remember, we call it as transconductance. Okay, transconductance.
Input is voltage and output is current.
Very good. Is this Harshada?
Yes, ma'am.
Okay, very good. So input is voltage and output is current. Because you write the gain as output by input. Is it not? You write the gain as ratio of output by input. So when your gain is indicating it's a transconductance, so it's the ratio of what we say output to input. So your output must be I and input must be V. Then only it will turn into formula of I by V. Right? Okay. So your input must be a voltage. So I must show it with the help of a voltage source. So this is the voltage source. Vs. Okay. So you know when we show a voltage source, we have to show its input resistance of the source in series with the source. So I will show here Rs. Okay. Now the voltage which is available between these 2 points is Vi, which is going to the amplifier. Okay. Now I'll try to show Ri. This is the input resistance Ri of amplifier. Now input is voltage. This is your input section. And output must be current. So I must represent the output of an amplifier with the help of a current source. So I'll show this is the current. So what should be the value of this current? Remember every time how I am uh, writing the value of this source or how I'm labeling this source. So to label this, first of all, I will write the gain. What is this amplifier name is transconductance amplifier. This is a transconductance amplifier, right? So how I will write it gain? Its gain will be represented by transconductance Gm, which is the ratio of output current to input voltage. Okay. What is our output current? Let's say IO. And what is our input voltage? Let's say VI. See, I have shown your VI. So output current can be represented as IO is equal to GM into VI, because this amplifier is producing the current, which is nothing but the output current. So I will represent this current source by GM into VI. GM VI. Got it? Similarly, here also, see, I wrote here II AI into II, which is nothing but the value of IO. Okay, this is a current amplifier. It will give me current. So I must write here the current, which is equal to output current IO, but I will write in this form. Okay, so this is our output current source. So I must show here RO. So this resistance form the output resistance of an amplifier, and at the output we will be connecting the load RL. Now let us comment as what we have to compare RS and RI. Now you people will tell me then RO and RL. Yeah, please tell me.
RS is less than of RL. RI, sorry.
Not better, you are not audible properly. I can't
RS
hear
is
you.
RI.
RS is less than RI. Very good.
RI.
I will say RI. RS must be very, very less than RI. Or you can also say that RI must be very, very high as compared to RS. So follow anything. So this RS must be less, very, very less than RI. What about RO?
RO is greater than of RL.
Very good. RO must be very, very greater than RL. Okay. Got it? Clear? The source
Yes, ma'am.
resistance must be very, very high as compared to input resistance of amplifier, and output resistance of amplifier must be very, very greater than RL. Okay, clear? You can write in reverse fashion also that RL, load resistance, must be very, very less than RO. Okay. You can write in this externally connected resistance. Same. Okay. So, is it clear? Shall we move for the last amplifier? Can you tell me how should be the connection of last amplifier? Yes.
Input is current and output is voltage.
Input is, which is our last amplifier? Trans resistance amplifier. So input is current, correct, and output is
Voltage.
now what?
Voltage.
Trans resistance amplifier. Let us draw it. So I must show input by a current source because input is current, and I must show output by a which source?
Voltage source.
Very good. So let's try to. So this is the input current source which I am going to connect, indicated by arrow, and I will call this source as IS. When it's a current source, there must be the resistance connected in parallel. Let's call this as RS. Okay. And this current source is providing current II, which is moving to the amplifier. The input resistance of amplifier, I'm indicating it by RI, And because it's a trans resistance amplifier, it will provide output as a voltage. So input is current and output will be voltage. So this is voltage source. Now you have to tell me what shall I label this voltage source as. Please tell me what shall I label this as. Yeah, please.
RMII.
RMII.
Very good. RM into II. That's nice. Good. Please keep interaction as it. Yesterday you have given very good Yesterday's lecture was very interactive. So keep the same into. I must show the grounds also. So you know the important thing, gain. Gain I am going to represent by RM because it's a trans resistance. So I will be showing it as RM. It is the ratio of output voltage VO to input current II. Then let's comment on RS and RO. Yes. How should be RS? Other students shall
RS is
also interact. Compare RS with RI.
RS is greater than of RI.
RS should be very, very greater than RI. And what about RO?
Is less than of RL.
Less than RL.
It should be very, very less than RL. Very good. So now you will understand what are the four different types of amplifier. What is the meaning of current amplifier, voltage amplifier, transconductance amplifier, and trans resistance amplifier. Okay. So everybody understood this? If your
Yes, ma'am.
concepts are clear, you can write anything. You can solve MCQ, you can write the answers. Okay. So we will move to the next now, feedback. So feedback we have already done that how we get a feedback. You have here the amplifier. You have an amplifier, then you connect the feedback network. You take some part of output and feedback to the input through a mixer. So in the feedback system, you give input through a mixer. So mixer receive two signal. One is the signal and another is a feedback signal. In this mixer, the signal gets combined. So either it will be additive or subtractive depending on the phase of the feedback signal. Okay. So if the input and feedback signals are in phase, we call it as positive feedback. If they are out of phase, we call it as negative feedback. We have also seen there are many advantages of negative feedback. Okay. Now today we will see the feedback topologies. Okay. We will see feedback topology. Very important. Remember, a question comes here for 8 marks. And you are expected to draw the block diagram and comment on the input and output resistance of this. Okay, so let's say what are the different feedback topology. Now you know that uh, the mixing takes place at input side of a feedback amplifier. So if I draw a feedback amplifier here, So now you will be giving input signal Vs. Okay. It will go to a mixer. Okay, this is your mixer. Then the output of mixer will go to amplifier. Okay, this is your amplifier. Then it will amplify. So this amplifier may be amplifier which is not providing any phase shift, or it may provide you 300 and 180-degree phase shift, like that of common source amplifier in the MOSFET, or like that of inverting op-amp. Okay, so it will either provide phase shift or it may not provide phase shift depending on that amplifier. Now here there is a network called as sampling network. Okay, we said that sampling network. What is the use of this sampling network? It takes part of the output. Means how much you have to take. Okay, suppose output voltage is 10 volts. So are you are you giving this whole 10 volt to the feedback network, or some part of that you are giving it to the feedback network? That is, so taking the part of output signal is done by sampling network. Okay, so the output of amplifier is available here, VO. Okay, it is providing VO. So output of amplifier is VO, but some voltage is taken by the feedback network. So this is your feedback network, or we will call it as beta network. Then it will provide feedback voltage, and this feedback voltage will go to the mixer. Okay, so here your VI. Now this is an amplifier which can provide you a phase shift. How much phase shift? Let's say 180 degree. Because see, in the negative feedback, what is required? In negative feedback, what is required? Input signal. In negative feedback, your input and output, between these two, there must be a phase shift. So input signal is first phase shifted by 180 degree. Okay, then part of that output is sampled and then it is given to feedback network. This is your feedback network. Now you want phase shift. If this feedback network again provide 180 degree phase shift, so what will happen? The signal will be as it is. We don't want that. So beta network shall not provide any phase shift. It shall provide, I will say, 0 degree phase shift. Remember, how much phase shift? It shall provide 0. Because if this is your signal, suppose this is your signal, for a negative feedback, you want phase shift in the signal. So amplifier is providing the phase shifted signal. Okay, here I will draw that. It is a phase shifted signal. Now this signal is going to beta network. So it will not provide any phase shift there. So the signal will remain phase shifted as that of output. Now this input signal and this VF, they are out of phase, therefore it's a negative feedback. But suppose you think that beta network is again providing 180 degree phase shift. So this signal after 180 degree phase shift will look like this. And if you check now, this and will be same. So because it's a negative feedback network, this will not provide any phase shift. Or if amplifier is not providing the phase shift, then beta network will provide the phase shift. Okay, but one at a time, not both. So what is the aim? That input signal and feedback signal must be, there must be phase shift between the input signal and the feedback signal. This is what we want to say. So this is how feedback is taking. So we have seen that two different important things here, that input signal is getting mixed here, and at the output of amplifier, sampling is happening. That is, some part of the output signal has been taken. So remember, there are two types of sampling and two types of mixing. Okay, there are two types of sampling and two types of mixing. Let me show you. Okay, here only I will show now. Two types of sampling means what are that sampling? This sampling may be current, series or parallel. Let me use whiteboard till that time. So what are the different types of sampling? Let's say first mixing. How the input signal and feedback signal mix? So there are two types of mixing. One is series mixing. Okay. Another is voltage mixing. Second is, extremely sorry. Another is shunt mixing, series mixing and shunt mixing. So what are the two different types of mixing? Repeat. Everybody. Come on, everybody. What are two
Series
types of
mixing
mixing?
and shunt mixing.
Where mixing happen? In the feedback amplifier, at input of amplifier or at output of amplifier? MCQ. Please answer. Where is mixing happening? Everybody. Everybody will unmute and tell me where mixing is happening. I
Input
guess
of
nobody.
amplifier.
Input.
Same student always reply, and some student never unmute themselves. So if you will be interactive, I will use these things. Otherwise, I have PPT to show. Okay, and I do understand at second year level if I show you all PPT. So for you might be difficult. Or shall we proceed only with difficulty? Shall I not use whiteboard? It will save my lot of time. Please tell. Is this whatever I'm drawing here? It takes a lot of time actually. But I feel that you shall able to draw this thing. That is why I'm doing such kind of complicated stuff using a mouse. Where mixing is happening?
At the
At
input
input.
of amplifier.
At the input. Where sampling is happening?
At the
Output.
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 So sampling is also having two types. Okay, what are those two types? This is, first is voltage sampling and second is current sampling. Okay. So very important. There are two types of mixing and there are two types of sampling. Whether your input signal is mixed in series, it will be called, it will be termed as series mixing. And if your signal is mixed in shunt or parallel mode, then it is called as shunt mixing. Similarly, if sampling, if what type of signal you are taking. So if you are taking the voltage output, then it is voltage sampling. If you want current to be given to the feedback network, it will be current sampling. Clear? Is it clear?
Yes, ma'am.
Now, remember important thing that when you want to sample the current, whenever you want to let's first talk about uh, mixing. So whenever you want to mix the signal at mixing stage, whenever it's a series mixing, so you will find that the amplifier, this was your amplifier. This was the amplifier, okay, and this was your mixer, okay, this was your mixer stage, and here there was a feedback network, okay. So mixing is happening at the input side, so that time you will find that series connections are established, okay. You will find that series connections are established. Now I will show you the mixing. Look here, only look at the look at this portion, how mixing is taking. Look here in this square, this was amplifier, this is our amplifier, right? This is beta network, okay, and this beta network is having some input and it has produced this signal. So how mixing will take place? So suppose you are applying voltage source, so this is how you are applying voltage source. So this you look at this connection, that in series mixing you are connecting the network like this. Beta network is connected, the output of beta network and input of amplifier, they are connected in series, okay. So one thing you will observe here, when you this series combination, this voltage and this voltage, they are mixed in series, okay. So what is the output of feedback network is voltage, okay. Now when it is a shunt mixing, so shunt mixing connections are, if this is the input source, in shunt mixing you will find beta network and amplifier, they are connected in parallel to each other, okay. They are connected in parallel to each other. So mixing happens at input side. In series mixing, the output of feedback network and input of amplifier are connected in series, and in shunt mixing, they are connected in shunt. So when it is series mixing, the input is essentially voltage. I will show you second case also. But right now, remember these connections. Okay. Right now, remember this connection, how it will be mixing. Clear? When I say series mixing, how shall be the connection? When I say shunt mixing, how shall be the connection? Is it understood?
Ma'am, please
Yes
explain
or
it
no?
once.
How is a series connection? Just a minute. How is a series connection? And how is a parallel connection? Suppose this is amplifier and you have connected here a voltage source. Okay, so you know voltage source, it is having its input resistance Rs. This is Vs. Okay. Now you will be connecting this to the amplifier. Okay. But now beta network is there, and this is the output of beta network. So in series type of mixing, you will be connecting both in series. Now if you apply KVL in this loop, okay, look here, this voltage across here, if this is Ri, voltage present here and the beta network. So this all connections are in series. If you want, how is the series connection? If I want to connect some resistances in series, so this is a closed loop. So I will say R1, R2 and R3 are in series. It is forming a closed path. If I want to connect two resistance in parallel, so I will draw this like this. So At one end these are common, at another end these are common. Okay, so similar way if I want to go for shunt connection, so this is, in that case, this will be a current source. This is the current source. Okay, now this is beta network. Shunt connection means, look here, one terminal is common, so this terminal I'll make it common with this, and this terminal I'll make it common with this. This is shunt connection. How two devices are connected in shunt. Understood? Remember how I have drawn. Remember here, series connection. Look here, it's forming a loop. Shunt connection. This network and this line and this line, they are connected together. Another line at end, they are connected together. Parallel connections or shunt connection at the input side. Here also, look at this. Look here. How the mixing is taking place. This is feedback networks, two terminal, and this is the voltage source, it's two terminal. So they are connected in series like this. If I want to make shunt connection, it will look like this. So this side, it's a series mixing. This is shunt mixing. So to have a shunt connection, your input source will be a current source. In shunt connection, input to the amplifier is current. In shunt connection, input to the amplifier is current. And in series, input to the amplifier is voltage. Input to the amplifier is voltage. Okay. Now, quickly I will tell you that as we said that there are two types of mixing and two types of sampling, right? We said that there are two types of mixing and two types of sampling. So accordingly, I can have how many? I can employ series mixing and I can use voltage sampling. I can use again series mixing and I can use current sampling. Similarly, I can use shunt mixing, voltage sampling, shunt mixing, and current sampling. So depending on how you, what you sample and how you mix, there are four types of feedback topologies. How many types of feedback topologies are there? Four types of feedback topology, and these are voltage series feedback. Now, how we will write this? The name of this feedback topology, let me tell you. There are four types of feedback topology. How many types? Four types of feedback topology. What are that? Now, while writing, you have to write first word of this as what you are mixing. And second word will be how you are sampling. Okay, so I can mix in, no, I just reverse thing. First word you will be writing as what you are sampling. And second, what you are, how you are mixing. So I can sample voltage. So whenever you sample voltage, remember voltage is available. If this is a resistance, I want voltage across this resistance. So I will get across this connector in parallel with this. Okay, so when my sampling is shunt, it means, when my sampling is voltage, I must connect this feedback network in shunt with the resistance. And when my sampling is current, then I must, how I will get a current? See here how it is connected. Here this is connected in shunt. Now look here, it is connected in series. This Here I am sampling current. So this current will flow like this, right? So current is flowing in this fashion. So connection of beta network and feedback, amplifier's output is in series. It's a series connection. And when I want to sample voltage, so voltage is available across here or at the two terminals of this amplifier. So I'll be connecting the beta network in shunt with that. Okay, so depending on that, I have either I can sample voltage or I can sample current. Okay, I can sample voltage and I will mix it in series. I can again sample voltage and mix it in shunt. Then I can sample current and mix it in series. And I can sample voltage and mix it in shunt. So how many feedback topologies is there? Voltage sampling, current mixing, voltage sampling, shunt mixing, current sampling, series mixing, voltage sampling, shunt mixing. Okay, so you have to write voltage sampling, series mixing, voltage sampling, shunt mixing, current sampling, series mixing, voltage sampling, shunt mixing. Okay, or in short, you can call that feedback topology as voltage series or voltage shunt, current series and current shunt. But remember, the first word is indicating how you are, what you are sampling, and second word is indicating how you are mixing. So when you are sampling voltage, you must remember that when I have to take voltage, I must connect my beta network in parallel with the output of amplifier. Look at this case. Okay. Look at this case as well. Is when I want voltage to be sampled, I must connect beta network in parallel with this. And when it is a series mixing, so remember, when it is a current sampling, then remember you have to connect beta network and amplifier's output in series. See, this is how the current flow in series. Current is flowing in series here. So this is current sampling. And this is voltage sampling. Understood what are the four different topologies? Say again. Yes, what are the four feedback topologies?
Voltage series,
Voltage.
Shunt, current, series.
current series, and current shunt.
Okay. Now you take one thing, do one thing. Take the screenshot of this. Take the screenshot of this. Okay. Now, whatever homework I have given you yesterday, you haven't did it. But I want this to be done by today. Draw this 4-block diagram. Everybody will drawing this 4-block diagrams. Okay. So this is a voltage series feedback topology. Voltage series feedback, current series feedback. This is voltage shunt feedback and this is current shunt feedback. Now, whenever I will tell you draw this, so you must able to draw it. So first of all, you understand, draw amplifier and draw beta network like this. This much portion. Oh, time up. Please keep me reminding for our attendance. No, I can't initiate it. Okay, fine. So we'll stop here. So 4 feedback topology. Next time, my question to you is, comment on the input resistance of this amplifier. This is your feedback amplifier now. Okay, this is your complete feedback amplifier. Which amplifier? This is voltage series amplifier. This is current series amplifier. Okay. This is current shunt amplifier. This is voltage shunt amplifier. Okay. Now my question to you as, when you have an amplifier, let's say its input resistance is Ri and output resistance is Ro, for only this much. Now, when you connect the complete feedback and you have a feedback amplifier, when your amplifier is a feedback amplifier, let's say now its input resistance is Rif and output resistance is Rof. Now you have to compare the Ri with Rif and Ro with Rof, only in the terms like whether it increases or decreases. पहले इथे लिया Ri, then write Ro. Simply show here either up arrows or down arrow. And I want this table for feedback amplifier. Okay. So for amplifier without feedback, if Ri and Ro are the resistance, what will be the effect on this resistance when you connect this feedback topology? Remember, when you are thinking of Ri, look at this side. And whenever you are thinking of Ro, look at this side. See how the connections are. These are parallel connections. So in parallel, this beta network resistance and outputs of amplifier resistance are coming into parallel. So what will be the net resistance? Here they are coming into series. So what will be the net resistance? So likewise, you have to make a table. Anybody from you is coming to the college, please let me know.